Hi everyone, welcome back. Today we are diving into GT power to look at how engine cycles change when we switch fuels and add forced induction. Specifically, we'll compare the PV diagram of a diesel engine and CNG spark ignition engine, both in naturally aspirated and turbocharged confusion. So first, let's look at the thermodynamic difference between diesel and CNG. In a diesel, as you can see, we compress pure to a very high pressure, inject fuel near TDC, and get auto ignition. This causes a rapid, sharp spike in cylinder pressure. You can see this on PV diagram as a steep, almost vertical pressure rise near the minimum volume. Okay, and on the other hand, CNG engine runs on a premix spark ignition cycle because the flame front takes time to propagate up through the gas-air mixture. The pressure rises smoother and peak pressure is more rounded. But what happens when we bolt on a turbocharger? Let's go to GT power. This is CNG PV diagram, okay? And actually, let me say, tell you the effect of turbocharging. Adding a turbocharger changes the boundary condition of this cycle, okay? Higher induction pressure, increased trap mass, larger loop area, pumping loop change, okay? So, look at the GT power results. That's how the starting point of the compressing stroke is pushed upwards because the intake manifold is pressurized. We trap more mass in the cylinder. This extends the entire PV loop since the area inside this loop represents the work output. The larger loop directly translates to higher torque and power. If we zoom in on the low pressure pumping loop, we can also see that turbocharger helps reduce pumping losses by keeping the intake pressure higher than the exhaust back pressure under matching conditions. And let's take a look at PV diagram on diesel. This is diesel turbocharged diesel engine. So in diesel, fuel is injected directly near top dead center into highly compressed hot air leading to auto ignition. You will see a steep pressure rise near TDC. The peak cylinder pressure is generally much higher and sharper due to the rapid premix combustion phase followed by diffusion combustion. And in CNG, that I explained to you, combustion is initiated by a spark plug and flame front propagates through the chamber, and the pressure rise is smoother.